Swayam Prabha. Digital India. Educated India.
Welcome back to the organ printing course. So this is the 8th week of this course. So in this week, we'll discuss about a few topics like first, medical modeling. That is, how can I convert medical image data to 3D models? And then also we'll discuss next step in 3D bioprinting, like what are the we have discussed various 3D bioprinting techniques, their applications, all these things. So in the also we'll discuss what are the different challenges and also what are the things that is required for this bioprinting techniques to take it to the next level, so that we can come up with new technologies for actually fabrication of artificial tissues and organs, so that organ printing, that name, could be successful, so that we can print really we can print functional tissues and organs. And then we can discuss different ethical issues related to biofabrications or organ printing. In this particular lecture, we'll discuss how medical image data can be converted to a printable file for bioprinting. Like, because organ printing, we have already discussed that if we have an STL file, then that STL file can be used for bioprinting. Like the printable file form, mostly it is in the STL format, stereolithography, that format. So that when we actually print a particular tissue or organ structure, any structure, that is, when we print, we need an STL file. We need an STL file, and that STL file should be generated by it can be generated by different ways. Now we'll discuss in this lecture, we'll discuss how the STL file can be generated and that can be used for bioprinting. We have seen that how bioprinting can be done. Suppose we have a STL file, then we can generate different types of biowings, and we can load that biowing to the bioprinter. We can load our STL file, and then the bioprinter will print as per our design, as per the thing it can print the structure. Now how this STL file can be generated, that is very important to understand. So in this lecture, we'll discuss that thing, how this can be done. And one of my student, Vijay Shankar, will help me to show you how this thing can be done. Actually, he will do this real time. He will do this conversion from medical image data to this STL file conversion. This thing can be done. Then after this STL file, then you are ready for bioprinting. Now, how this thing can be done? Now, suppose, because bioprinting is mostly, here we are talking about customized 3D printing, customized structure fabrication, and also it is like mostly we are trying to develop different tissues and structure for a particular patient. So that means customized, again customized tissue structure, organ structure. So that can be done with the help of different medical image modalities like CT, MRI, USG, ultrasound. All these different techniques can be very well used to generate medical image data. So this medical image data, that is mostly, it is like in CT, we get slices of a particular target tissue structure. So we can, when you get different slice, like but n number of slices for a particular tissue, then this slice carries information from that particular slice of that tissue structure. Now when you combine all these slices, then we can get the whole 3D geometry of that particular tissue structure, right? So that's why this, for medical imaging, we can get that 3D image data, and then again that can be converted to STL file. So there are ways to do that. And another thing to remember here, this medical image data, mostly it is in the format of in DICOM format. Then it is our job how this DICOM format, that medical image data that is present in slices, that can be converted into a STL file, and what are the different ways we can convert them, what are the different softwares we can convert them, and how we can again manipulate that thing with the help manipulate that thing with 3D printing technique. No, sorry, manipulate that with using some 3D modeling software to come up or to delineate that tissue structure, that is our target tissue structure, from that from the 3D image, and again then we can use that to generate that STL file where only the target tissue can be there, target tissue structure can be there, other structures, suppose the other structures can be eliminated or can be removed from that thing, and then that can be used for further uh, 3D printing of that thing. So in this lecture, we'll discuss all these things, how this medical image data can be converted to a 3D model, and then that can be used for bioprinting applications. Now my student Bijay Shankar will show you how this process is used, what is the process, like how this medical image data can be converted with the help of a particular software.
So in this session, we will see how medical image data can be converted to 3D models for the purpose of organ printing. So as we know, in 3D printing, the entire process starts with a 3D model, right? So we can create this 3D model by way different techniques. Either we can create the 3D model using conventional 3D modeling tools such as the AutoCAD, Solid Edge, etc. For creating, we can use such softwares for creating 3D models. Else, we can depend on medical image data to create or to reconstruct the exact desired, the object with exact desired shapes. So especially when it comes to medical 3D printing, we depend more on medical image data such as CT, MRI, etc. for creating 3D models. So for example, on the right side, what we are seeing is a process of creating a 3D model or printing a physical model from a scanned data. So it starts from the medical imaging such as CT or MRI, and then this is converted to a 3D model, a virtual model, and then this is 3D printed using 3D printers to obtain final physical product. So here we will discuss further how the first step where we convert medical image data to 3D model works. For such a process, as we have seen already, that we need medical image data. So medical image data can be MRI or CT, or it can be ultrasound or PET CT. So here, apart from this, we can also depend, or we can also use 3D scanning techniques, but 3D scanning is mostly used for exoskeletal applications such as the development of prostheses, orthoses, etc. Whereas other techniques will allow us to create the or extract the internal structure details. So now we will see what are the available tools using which we can convert medical image data to 3D models. So we have softwares, different softwares available. We have both open source and license the softwares available. So some of the softwares are listed here: 3D Slicer, Invis Alias, Mialite, 3D Viewer, Dragonfly, ATK Snap, Mimix, Osiris, etc. So one of the most commonly used software is 3D Slicer, which is again an open source software. And for this particular session, we will see how medical image data can be converted to 3D models using the software 3D Slicer. So the first, we need to download this 3D Slicer software from the parent websites slicer.org. And there are different steps involved in this process of converting medical image data to 3D modeling. So we will see one by one what are the different steps involved in the entire process of converting the data to 3D model. So first we will see the 3D Slicer interface, and then we will see how can we load the data to the 3D Slicer interface. Then we'll go to the volume rendering and cropping section, and then we will see creating label maps, and later on we will also see how can we convert this into surface models, and these models, how these models can be converted to 3D printable formats. So all these steps we will see in detail.